Hello friends, welcome to Shiksharthi. In this video, we'll again be talking about quadrilaterals under the head of geometry. So let's start. So now in this video specifically, we'll be talking about three different types of quadrilaterals, and those quadrilaterals are, we'll be talking about rectangle, square and a rhombus is what we are going to talk about. So if you have gone through my earlier video on parallelograms, this is what we had discussed in the earlier video, and many other things other than these. So if you've gone through it, can we say that even a rectangle is a parallelogram, right? At the same time, can we say a square is a parallelogram? And finally, can we say that rhombus is also a kind of a parallelogram? So the focus in this session would be talking about various properties of all these three different types of quadrilaterals, and then trying to convert them from a parallelogram to a said quadrilateral. Let's say whether it is a square or it's a rectangle or it's a rhombus. This will be the objective throughout. Okay. So now we know that this is a parallelogram. Why do we know this? Because this is the piece of information that is already given to us. AB is parallel to DC, and at the same time AD is parallel to BC, and not only are they parallel, they are equal as well. For example, this is equal to this and this is equal to this, which is why the resultant figure that we get here is a parallelogram. And then we talked about various properties of the parallelogram. Okay. Now if I say that the vertex angles, we already know that the opposite vertex angles of a parallelogram are equal. For example, this angle is equal to this angle, which is angle B is equal to angle D, and the next angle that we are talking about here is angle C is equal to, angle C is equal to angle A. Now, if I impose a condition on this parallelogram, and the condition here is A plus D, if A plus D is equal to a 90 degrees, right? Can I say then B plus C becomes equal to 90 degrees? Yes, because we know that in a parallelogram, the sum of alternate angles alternate one after the other. So this angle A plus angle D is equal to angle D plus angle C is equal to angle C plus angle B is equal to angle B plus angle A, which is equal to 180 degrees. Right? We already know this. So using the same property now, so if I say angle A plus D is equal to 90 degrees, in that case angle B plus C becomes equal to 90 degrees. And if I say angle B plus C is equal to 90 degrees, then angle A plus D also becomes equal to a 90 degrees. Once we say this, the resultant figure that is formed becomes a rectangle, wherein the rest of the properties as we had talked about in a parallelogram would be same as the properties of a rectangle. What are the properties? The diagonals are, do the diagonals bisect each other? Yes. But here in a parallelogram, there will be some changes, with some changes. For example, the moment I make this change, angle this is equal to angle this, that means in that case, now let us talk about what is the second thing that we should talk about. So we know that AB, the length of the line segment AB is X. We have already assumed, as we had assumed here. So the length of the line segment AB is equal to the length of the line segment DC, which is equal to X, and the length of the line segment AD is equal to the length of the line segment BC, which we have assumed it to be a Y. So once we know this, so what are we saying? We are basically saying, here now we need to understand. So is this, we already knew that these are triangles which are, are they congruent or are they similar? So we proved that they are congruent. Same was true with this. So we again have a pair of triangles. So this pair and this, this pair, when we talk about they are congruent to each other, and this is another pair of triangles which is congruent to each other. So now, and at the same time, we know now from Pythagoras Theorem or from elsewhere, what is elsewhere? We know that we could have talked about this triangle and this triangle. So we know that triangle ADC is congruent with triangle ABC. Why? Because you have a common side, and then various properties of congruency you can use here. Either you use triple S, or you use SAS, or you use ASA, right? Many other properties you can use here, or you use double AS or RHS. So let us say I want to use an RHS here. So can I say these two triangles are congruent? Yes. Can I say this triangle and this triangle are congruent? Yes. So therefore you would say that the line segment AC is equal to the line segment BD, and they get bisected also, which is this. So can I say AE, if the point of intersection of both the diagonals is E, can I say AE is equal to EC? Yes. Is equal to DE? Yes. Is equal to EB? Yes. Next, these pair of triangles that we were talking about, these are isosceles pairs. And when we say that these are isosceles pairs, what do we mean by this? So if this, we know that these are isosceles pairs. So in that case, this angle, if this is B, this becomes equal to A. At the same time, angle C becomes equal to D. This is the point that you need to understand here. So what we are saying is angle B becomes equal to angle A, and the same here. And at the same time, angle C becomes equal to angle D, which becomes the same here as well. Next point, which is very, very important here is, and then you can talk about the areas. I have divided this. So can I say this? We already know that a parallelogram gets divided into 4 equal areas once the diagonals bisect each other, and there are 4 triangles which are formed. The same here I can say. So the area of this triangle is x into y by 4, here x into y by 4, here x into y by 4, here also x into y by 4, and this can be proved also. Now if I wish to know what is the area of this, now when I say this, what am I saying basically? Can I say if I am dropping a perpendicular from here to here, this perpendicular is not merely a perpendicular, it becomes a perpendicular bisector as well. So this is where you will be using all the 4 geometric center properties that we had talked about in 4 different videos. So meaning thereby, the length of this, if I assume that this point is, let's say F, right? This is the point F, and this point is already E. So can I say EF is equal to X? This is Y by 2, this entire length is Y, and so this becomes Y by 2. And the same I can say for EB. So EB becomes how much? FB becomes how much? FB becomes X by 2. So can I find out the area of this rectangle? We are talking about the rectangle FB. Let's say this is G and this is E. The area of the rectangle FBGE is nothing but length into breadth, which is x by 2 into y by 2, which is nothing but xy by 4. So you will see that this is nothing but just like saying, the area of this triangle is just like saying this triangle plus this triangle, which makes the entire rectangle here. This is the point to be observed by you. Okay, next point which is very important here is, now if I say in this parallelogram, if this happens to be the midpoint, this happens to be the midpoint of this side. Let's say this is the midpoint of this side and this is the midpoint of this side. And now I join these points. So the resultant figure that I am going to get here is a parallelogram. So this I can prove by what? I can prove it by BPT, which is basic proportionality theorem, or an offshoot of basic proportionality theorem, which is nothing but midpoint theorem. So from midpoint theorem, we'll be able to prove that these two sides are parallel and so are these two sides. And once we know that, now this side if I talk about, would be half of this side. And same, I think we will say for this side is half of this diagonal. And we know that both the diagonals are unequal. So now if I'm getting a resultant figure, in which I'm getting these are two pair, this is a pair of sides parallel, another pair of sides parallel and equal. One pair parallel equal, another pair parallel equal, and then I divide it into in terms of angles also, which I'll be able to divide. Right? So the resultant figure that you are getting, let's say the resultant figure that you are getting here is a PQRS. So what is the learning from here? The learning from here is, if I take a parallelogram and then bisect the sides of a parallelogram, we are talking about the midpoint of the sides of the four sides of a parallelogram, and then I join the midpoints of all the four sides, the resultant figure that I get here is another parallelogram. The same thing now I am talking about a rectangle. So you can use all the properties or all the discussion that I did here for a rectangle, and henceforth you will be able to say, so if I join the midpoints, this is the quadrilateral that we get. Is it a parallelogram? I mean, we know that every quadrilateral, if I say every quadrilateral, I am basically talking about rhombus, rectangle, square, and a parallelogram itself is a parallelogram only. But then there are some additional conditions which need to be imposed. I mean, no doubt it is a parallelogram, but the additional condition here is we know that for a parallelogram, both the diagonals do not intersect at right angles, and here both the diagonals would intersect at right angles. So we know that, I mean, though we'll come to know in few minutes, that there are only two quadrilaterals in which the diagonals intersect at right angles. We are talking about any two among these varieties. So which are those? One is rhombus and the other one is a square. And not only this, in a square, even the vertex angle which is 90 degrees gets bisected, which is not happening here. Henceforth, the resultant figure which is formed inside by joining the midpoints of the sides of a rectangle, the inside figure that is formed is a rhombus. Taking this discussion forward, now if I want to convert this parallelogram into a rhombus, I know that how is a rhombus formed? So rhombus is formed with the help of angle bisectors, which is why those four geometric centers were discussed. I repeat this. Okay. So now when I say angle bisectors is how a rhombus is formed, then the condition that we need to impose on a parallelogram is this angle should be bisected. So if angle A is equal to angle D, and at the same time we say angle B is equal to angle C, then can I say that the resultant figure that will be formed will be a rhombus? Let's see. So we are saying, so I have taken the same figure, though the only thing that I have done is I have just reoriented it slightly, and I am using the same thing. These are angle A's, angle B, angle B, angle A, and angle B, angle B. So what are we saying here? So using the property of a triangle, all the interior angles of a triangle, and at the same time we'll say that this angle is equal to 90 degrees. How are we able to say this? We know that this angle is either A plus B or D plus C. Now in this case it will be A plus B only. So we are saying the sum of all the interior angles of a quadrilateral is equal to how much? 360 degrees, which can also be proved. So 4 times of A plus 4 times of B makes it 360 degrees, which is what? A plus B is equal to 90 degrees. Henceforth, we'll be able to say that the diagonals of a rhombus merely bisect each other. That is okay, but they do not merely bisect each other. They bisect each other at right angles. So these are perpendicular bisectors. So a rhombus is formed with the help of perpendicular bisectors being drawn. And thereafter, these are angle bisectors here. Okay, taking it further. So we already know that the length of the sides here. Now the length of all the 4 sides would be equal. That can be proved by congruency whatsoever. I mean, can I say all these 4 triangles are congruent? Yes. This is point number 3. I repeat, all these 4 triangles are congruent to one another. Okay. Now when we say that all the 4 triangles are congruent, what are we saying basically? We are saying if the length of this side, so let's say this is x, this is x, this is x, and further this is also x. And we know that, let's say that here this length is y, this length is y, this length is z, and this length is z. So we can use what? We can use triple S. We can use any property, any test, any criteria for testing the congruency, and one of them is a triple S. Okay. So can I say all these 4 triangles which are congruent to each other are scalene triangles? Yes. So this is slightly different from what we discussed here. All these 4 triangles are isosceles triangles. Okay. The last discussion with respect to a rhombus. So if I join the midpoints of the sides of a rhombus, the resultant figure that I am getting is which figure? So from here you will be able to say Which figure is this? I mean, can you figure it out? Can I say it is a rectangle? Maybe. So from here you can say that using some logic here. What is the use of logic? Inside a rectangle joining the midpoints of the side, I was getting a rhombus. So inside a rhombus joining the midpoints of the sides of a rhombus, the resultant figure that we get inside is a rectangle. That can be proved also. Again, proved by what? You can prove it with the help of midpoint theorem or BPT. So once we know that the length of this side was 2z, so can I say all these would be z each? All these would be y each? So we are saying the length of one side is 2y and the length of another side is 2z, right? And the vertex angles are what? 90 degrees. So which figure, I mean, if I talk about a quadrilateral, which quadrilateral among these 4 quadrilaterals that we are talking about has a vertex angle equal to 90 degrees? One of them is a square and the other is a rectangle. Now since this cannot be a square because one side is 2y and the other side is 2z, henceforth the figure that is formed inside is what? Is a rectangle. Then last but not the least, if I want to convert this parallelogram into a square, all I need to understand here is this is just a shade ahead than this or ahead to this. So the very first thing that you should do is convert a parallelogram into a rectangle, from a rectangle to a rhombus, from a rhombus to a square. So square becomes your destination point. Okay, so can I say if A is equal to B, which is just like saying this, so it's just like saying the vertex angles should get bisected. So if A is equal to D and B is equal to C is what the property of a rhombus was, if I equate all of them. So it is just like saying if A is equal to D is equal to a B is equal to a C, then I get the value of each of them as 45 degrees. Okay, and then you can do the same thing as we have done in other cases. For example, if I want to calculate the length of the diagonal in case of a rectangle, it is nothing but I can just use a Pythagoras theorem here, which is just like saying under root of x square plus y square. The same thing I can use here also. So which is just like saying x root 2 and x root 2. Then talking further, as we had talked about other points here. So what are these 4 triangles that I am getting inside? All these 4 triangles are congruent to one another, that is correct, but they are what? Are they isosceles or equilateral? They are isosceles. So how is this discussion going to be different from a rectangle? Now here all the 4 triangles that you are getting inside, all of them are congruent triangles to one another and they are isosceles. But in case of a rectangle, you are getting pair of, I mean, though all the triangles are congruent, but you are getting pair of congruent triangles. This pair is congruent and this pair is congruent, but this pair is not congruent to another pair, which is happening in case of a square. So from square to a, let's say from a rectangle to a square, if I want to go, the isosceles triangles that you are getting inside, all of these triangles should be congruent to one another. Then last but not the least, so if I take the midpoints of the square and the resultant figure that I get inside, using some logic here by now, I can say I'll be getting a square, though I can prove it mathematically. If you feel that something very knowledgeable has been discussed in this video, please do not forget to like, share and subscribe to our channel. If you have already done so, please click on the bell icon and select all so that you start receiving updates from us regularly. If you want us to do some specific videos on some specific topics, please put it in the comment section so that we can do it for you. Thank you so much. Until next we meet, goodbye.